Hey everyone, this is Team Orbital presenting you with a technical presentation. So, our journey to the open house. So, during the buildathon, we built a product called AMM protocol, which is called Orbital. So, it was based on a design by Paradigm, in which you can trade multiple stablecoins within a single pool. So, there runs complex maths behind it, governing all of it. But in a nutshell, it's an AMM protocol where you can trade multiple stablecoins. It gives you good gas efficiency, it gives good returns to liquidity providers, and it gives very less slippage. And you don't have fragmented liquidity. So during the hackathon, we built an MVP in which you had certain restrictions. You could add liquidity with some constraints. You had a functional swap, but it was not efficient. It was not giving really good returns, and it had overall less efficiency. So to take this from an MVP to a final functional product, we did some certain changes. So we made a tremendous amount of progress in this, and let's look into that each of them by deep. So we first of all we changed the data type to improve precision. We implemented trade segmentation. We built APIs, and we built a functional demo for you guys. So let's look into first. So converting U into 56 into Q96 into 48. So firstly, the calculations were done in U into 56, but by converting into Q96 into 48, it has made our calculations very precise. So we have an arithmetic format using 96 bits for the integer and the 48 bits for the fractional part. So it is very gas efficient, and because this is based on bitwise operator and it's done on stylus. And the second thing is implementing multiple liquidity provider in single tick. So this is what we've done beyond the white paper. The white paper only allowed you to have single liquidity provider for a single tick, but we expanded it and we made it for multiple liquidity providers. And we implemented the trade segmentation part. So now you can have a very big swap that's done. So let's look how it is exactly it's done. So imagine you have two buckets of tokens, tick A and tick B. So these were the boundaries, and tick A allows prices to only move up to 99%, and tick B allows 95%, and they have 1000 tokens. Now suppose if someone wants to swap 30 tokens. So if all 30 tokens will be swapped from tick A, the price would fall to 97%, which is not allowed because there's a rate limit. It's up to 99% only. So instead of this, the trade is split. Take 10 tokens from tick A and take the remaining 20 tokens from tick B, since it allows more precise movement. So this process of splitting a trade across multiple ticks to respect the rate limits and for the investors, this is called trade segmentation, and it really improves our efficiency. So, and on top of this, on top of Orbital, we've built an API. Seeing the current market needs, every AMM protocol or every DEX must have their API so other people can use the benefits of that. So we've built an API for Orbital. So now other developers can have our API and they can do swaps and they can integrate it within their projects. So that increases our reach for the Orbital. And why we chose Arbitrum from this? Because first of all, Arbitrum has inbuilt MEV protection. You can only protect from MEV attacks, and it's obviously gas efficient because we did the same code in Solidity versus in Stylus, and the data is shown for a respective very small function. So a very small function which is being done a lot of times, and there's a difference between gas, and this difference between gas compounds over the whole protocol or whole functions. So it turns out to be pretty big value. And let's head to the demo right. Interface of our orbital. So we've significantly improved the user experience and we have worked on the interface. So now you can have much better explanation of our project, and we also had demonstrations to help users visualize how exactly deep inside it's working. So and like how the progress is, everything working, like what checks are being testing and everything. And we've added documentation. So we've added documentation for the protocol and for the API. So for API documentation, you can just click and you have your API hosted. So you can just go there and go on your CLI on a terminal, just test our APIs, and you'll get. You can also swap with them. You can integrate in there on your projects and everything. So this is a liquidity interface. You can add and remove a liquidity here. Actually, we implemented multiple liquidity providers in the single tick. So due to that feature, we were not able to integrate into the front end. So because that makes things a bit complex. So we're doing that from the RCLI face of our orbital. So we've significantly improved the user experience and we have worked on the interface. So now you can have much better explanation of our project, and we also had demonstrations to help users visualize how exactly deep inside it's working. So let's go to that. So this is the CLI command which will run to add liquidity. Its parameters are adjusted according to the code, and let's click run. Yeah, so the liquidity got added and we have all the transaction data here, and we have the swap interface. So for swap interface, we have that basic swap interface for trading between tokens. But why should we do a conventional swap? Let's do it in some interesting way. So let's head to that. Right? So let's go to that. So this is the CLI command which will run to add liquidity. Its parameters are adjusted according to the code. Real life applications of Orbital, how it can be integrated with real life protocols. So like recently Google released a new protocol called A2A X402. That is basically integration of X402 protocol with A2A agents. So like now agents can pay each other cryptocurrencies with like stable coins, for example USDC. And what we done has we routed that all of this through the orbital. So now like the other agent wants like USDC, we have USDT, so we can just route it through our orbital to swap it and then pay him. So let's look at how it's done. It's completely automated. So let's say I want to buy banana. By the way, that value is in let's see. So that value is in 10 to the power minus 18, and let's approve this transaction and let's see the logs. How exactly are we getting? And let's see the transaction hashes. We'll fetch the transaction hash from these logs. So we can see the X402 transaction hash we got it. So we can see we send this much amount of USDC. This is X402 transaction hash, and the orbital hash is here. So yeah, it swapped it from token 1 to token out and we got these values. So that's how it's done.